Till now, we have been aware of light spectrum. Now, let's get acquainted with electromagnetic spectrum. Electromagnetic waves are waves that are capable of traveling through vacuum. Unlike mechanical waves that require a medium in order to transport their energy. They are capable of transporting energy through the vacuum of outer space. That means electromagnetic waves can transport energy through vacuum. They are produced by a vibrating electric charge, and as such, they consist of both an electric and a magnetic component. That is why they are named as electromagnetic waves. Electromagnetic waves exist with an enormous range of frequencies. You know, each wave has got a frequency. So, wide range of frequencies are there with electromagnetic waves. The continuous range of frequencies is known as electromagnetic spectrum. The electromagnetic spectrum is the range of all types of electromagnetic radiation. Now, what do we mean by radiation? Radiation is the energy that travels and spreads out as it goes. You know, the visible light that comes from a lamp in your house and the radio waves that come from a radio station are two types of electromagnetic radiation. And the other types of electromagnetic radiation that make up the electromagnetic spectrum are microwaves, infrared light, ultraviolet light, X-rays, and gamma rays. The electromagnetic spectrum is all of the different forms of radiation put in order from lowest energy to highest energy. All of these forms of radiation travel at the speed of light, but only some of them are visible. Here you can see a range of electromagnetic radiation starting from the ones with the lowest energy, and you can observe the change in the wavelength and the frequency as you are moving from radio waves to the gamma waves. So, the arrangement of electromagnetic waves in accordance with their increasing or decreasing order of frequency or wavelength is called the electromagnetic spectrum. That means all the electromagnetic waves might be arranged in the increasing order or decreasing order of frequency or wavelength that forms an electromagnetic spectrum. The electromagnetic spectrum broadly contains 7 different kinds of electromagnetic waves. In the increasing order of wavelength, the waves are, that means when you talk of the wavelength, the increasing order of the wavelength, the waves are gamma rays, X-rays, ultraviolet rays, visible light, infrared rays, microwaves, and radio waves. That means gamma rays will have the least wavelength and the radio waves will have the maximum wavelength. Now, there are some properties which are common to all the electromagnetic waves. Let's see which are those properties. First, they do not require any material medium for propagation. That means they can travel through vacuum also. Apart from, like you did sound, sound doesn't travel in vacuum. They all travel with the same speed in vacuum, with that speed of light, which you're familiar with. That means all the electromagnetic waves will travel with the speed of light, that is 3 into 10 to the power of 8 meter per second. Third, they exhibit the properties of reflection and refraction. They are not affected by the electric and magnetic fields. They are the transverse wave. So you can see that these are the 5 properties which are common to all the electromagnetic waves, that they can travel through vacuum with a speed of 3 into 10 to the power of 8 meter per second. They exhibit the properties of reflection and refraction. They are not deflected in the electric or magnetic field, and they are transverse in nature. Now, you know, all the waves have a particular frequency and they have a wavelength. So, what you need to remember or recall is that wavelength and frequency can be interconverted, and they have an inverse relationship. The relationship is given by V is equal to C upon lambda. This, you know, is obtained from the fact that velocity is equal to the product of frequency and wavelength. So here, nu is the symbol for frequency, lambda wavelength, and C is the speed of light. So you can see that frequency and wavelength are reciprocal. I mean, they have an inverse relationship. If frequency is more, then the wavelength will be less. Or if frequency is less, then the wavelength will be more, and vice versa. Now, wavelength is given in nanometer. 1 nanometer, please remember, is equal to 10 to the power of minus 9 meter. And wavelength is also represented in angstrom. The symbol for angstrom you can observe, and 1 angstrom is equal to 10 to the power of minus 10 meter. The frequency is given in the unit per second, or 1 upon S, and it is known as hertz. The symbol is Hz, like kilohertz on the radio.